Okay, this is A.REI.3, Algebra, Reasoning with Equations and Inequalities Standard 3, Video 10, Solving Absolute Value Inequalities. Here are a few terms to know. I'd like you to copy these down in your journal and define them, please. It says solve the inequality and graph your solution. So we're going to be graphing our answers on the number line. And we know that with inequalities, we may have multiple answers. So it says the absolute value of x such that it is greater than or equal to 6. So I'm just going to start by grabbing a random number off the number line that happens to be larger than 6. So I'll say, let's say x could be possibly 8. So if I were to take the absolute value of 8, is that going to work? Well, the absolute value of 8 is 8, and 8 is greater than or equal to 6. So I would say yes, that is a solution. Now, when we were graphing absolute value equations, we knew that there might be another side to the answer. We know that 8, 9, 10, and anything larger than or equal to 6 would work. But what about all of those possible negative values? What if we were to plug in number values that are negative, but their absolute values are greater than 6? So let's just choose one. How about negative 10? If x is equal to negative 10, I know that negative 10 is not greater than or equal to 6. I do know, however, the absolute value of negative 10 is greater than or equal to 6. So let's test that out. Okay, absolute value of negative 10 is 10. And that would also work here. So how are we going to get all of the values that will make this statement true, whether it be 0 or either side of 0? So your positives or your negative values. All right, so we're going to set up a little process here. So the process is we take the inequality, take the braces off of the absolute value. So we'll x is greater than or equal to 6, and then x is less than or equal to negative 6. Now the reason why we flip the symbol is because we know that anytime we change the value of our integer, so we went from 6 to negative 6, we know that we divided by, or in some cases multiplied or divided by a negative. So that in turn would cause us to turn our symbol the other way. Okay, and if we were to graph these two inequalities, my numbers in question, I have negative 6, I have positive 6, and if you would like, we can put the center point of being 0. And we choose we look at our symbol and we ask ourselves, should it be an open circle or a closed circle on these values? And we've learned that if it has an equal sign, it's including those values. So we know that we include 6, it will work. And we will be shading, it says to the right, so it's greater than 6. And the arrow is important. And then including negative 6 and all values that are less than negative 6. Okay. Same idea. Solve the inequality and graph your solution. So now we have an additional step. X is not by itself. We have a value that is being subtracted, and it happens to be subtracting 5. So we get rid of all of our inverse operations on the outside of our braces, which, there aren't any in this case. So we are ready to take these absolute value brackets off and set up our two inequalities. So we have x subtracted by 5 is greater than or equal to 7. That will get our basic answer that we easily could have figured out in our heads. And then what's the other possible answer? Let's take the brackets off. And then we are turning the symbol and changing our sign. Now since we changed our sign, we had to flip that symbol once again. All right, so let's solve both of these. Add 5, inverse operation, add 5 to both sides. So x, bring down our symbol, is greater than or equal to 12. And then x is less than or equal to, add 5 to both sides, we have -2. And let's see what that looks like on our number line. So we have -2, we have 12. Once again, we have closed circles. These answers are all included, so -2 and 12 are included in the solution portion. And now what direction do we shade? So greater than 12 would be to the right. And then less than or equal to, we go to the left. And this is another one of those opposite direction answers. So we could call this a union. So that means we have an OR statement, also known as the union. Okay, last one. Inverse operations state, let's work our way towards the brace. So let's try to get all of the stuff on the outside of this inequality over to the right. So the inverse of adding 3 is subtracting 3. Subtract 3 from both sides, and we get a 6. Okay, so we got rid of all of our numbers on the outside, so let's figure out our solutions here. Take the braces off. And let's get the other side of our values. Flip the symbol, change the sign, and let's see what this all ends up being here. All right, add 5 to both sides. What are we going to get? -5 and 6 is 11. Divide both sides by a -4, so be careful. Since we're dividing both sides by the -4, our rule is always to flip the symbol. So x is greater than -11/4. And let's work on the right here. Add 5 to that, so greater than -1. Divide both sides by the coefficient of -4. Once again, we have to flip our symbol because we divided by a negative. So less than 1/4. Okay, our numbers in question. We have the +1/4 and the -11/4, which you know if you turned it into a mixed number would be -2 3/4. And let's graph the solutions here. All right, so it's an open circle. These values are not included as solutions. And we have greater than, so we're moving to the right. And then this one is less than 1/4. That one is moving to the left. And we have our intersection here. This is an AND statement. So all of the numbers on the number line between -11/4 and +1/4, not including them, will be solutions to this original inequality up top. Okay, in your journals, please define the given terms on page 2 of the flip chart. Write a few sentences on what you have learned from this video. If you have any questions, please write them down on your paper, bring those to class, and we are also going to be putting some word problems in here. We're going to be doing some real world applications with these inequalities and absolute value. See you in class.